So let's derive the phenotypic variance under the Mgcta model using path tracing rules. So recall that in path tracing rules, when we want to find the variance of a variable, we basically trace backwards along an arrow and then forwards along an arrow back to the variable of interest. And each of the path coefficients in that particular chain are multiplied together. We do that for each possible chain of paths, and then we add those different chains together. So let's have a look at the Mgcta example. So one chain back from the offspring phenotype is along this M path. So we would take M, multiply it by 1, going round this double-headed arrow, and then back along M. So we've got M multiplied by 1 multiplied by M, or M squared. Remember that in each chain, we can only go through one double-headed arrow. Another possible chain is down through this C path. So if we go down here, we have C multiplied by 1 multiplied by C, which gives us C squared for this path. Yet another path is H multiplied by 1 multiplied by H, so H squared, and then the residual path, so E multiplied by 1 multiplied by E, which is E squared. Now, there's actually two more paths that we need to take account of, and they arise because of the correlation between maternal and offspring genotypes. So note that we can go from P back along the M path, down this double-headed arrow, and then up the C path. So that's M multiplied by 1/2 multiplied by C. Remember, with each chain, we only go through one double-headed arrow, which is this one here. So we're not going round this path here or round this path here. So this is us going anti-clockwise around this little chain here. But of course, we could go back the other way as well. So that's C multiplied by 1/2 multiplied by M. So when you add those two chains together, 1/2 MC plus 1/2 MC, that equals MC. So you might remember the expression, the variance of a sum is the sum of the variances plus twice the covariance. Well, that's exactly the same thing here. You've basically got the variance of a sum. You're summing the different variance components, but then you have to take into account twice the covariance because mums and offspring genotypes are correlated. So that's the variance of the offspring phenotype under the maternal GCTA model. In the next video, I'm going to be talking about deriving the phenotypic covariance between pairs of individuals under maternal GCTA.